Hi, this is Maggie. In this video, we're going to examine a Python program dynamically, as it's running. Before we get started, I'm going to quickly give you some tips for how to get the most out of this video. First, if you have problem solving with Python, read up through Chapter 2. If you don't have it, you can still learn a lot from this video. Open up idle and follow along with Python as I work. Sometimes I'm going to suggest you pause the video and complete some steps on your own. When I do that, pause the video and do your best to complete the steps on your own. The way to learn to program is by programming. You can watch and learn if you work along with me. Remember, you can always pause the video and try something, or go back and watch again. You don't have to wait for me to tell you to pause. There are some automated exercises in the description of this video. The exercises work with the same code or similar code to the code in the video. After you've completed the video, try the exercises to cement the concepts in your mind. Now let's get started. There are two important dynamic aspects of a program: the program state and the flow of control. The program state is what variables are defined and what values are in them at each point during program execution. The flow of control is the order in which statements are executed. Right now, there is only one flow of control, sequential, or top to bottom, in the program file. This is the default flow of control. Once we cover logic and the statements that use logic to branch and loop, we'll see other orders in which statements can execute. We will begin by stepping through our program in the debugger. The program that I have here is a program that we wrote in a previous video, which I'll link here in case you haven't watched that video yet. I have it open in Notepad++ as well as idle, because in Notepad++ we can see the line numbers. Now first, let's identify the executable lines of code. The executable lines of code are the lines of code that will make a change to the program state. Lines of code that will assign to a variable or print to the screen. Lines of code that are not documentation. I'm going to read the program for any viewer who is visually impaired, but if you can see the program on the screen, you can jump to the pause button. What I'd like you to do is pause the video and identify the lines of code that are documentation. Line 1, docstring. Obtain an ideal adult dog weight from the user. Line 2, then calculate and display the appropriate meal weight, end docstring. Line 3, blank. Line 4, all caps, meal weight percentage, float equals 0.03. Line 5, dog weight, float. Line 6, meal weight, float. Line 7, blank. Line 8, £, obtain the dog's ideal adult weight from the user. Line 9, dog weight equals float, input, please enter the dog's ideal adult weight. Line 10, blank. Line 11, £, calculate the weight of the dog's meal. Line 12, meal weight equals dog weight times meal weight percentage. Line 13, blank. Line 14, £, display the weight of the dog's meal to the user. Lines 15 and 16, print the meal for a dog weighing, curly braces, pounds, should weigh, curly brace, 0.2f, close curly brace, pounds, end string, dot format, dog weight, meal weight. Again, what I'd like you to do is pause the video and identify the lines of code that are documentation. Pause now. Okay, how did you do? Did you identify all the lines of code that begin with a £? Those are lines 8, 11, and 14. Those are comments, and Python ignores them. In addition, you may have identified the docstring at the top of the program and the two variable annotation on line 5 and 6. Those aren't really executable lines, but they're in a sort of gray area because they do contribute in a way to program state. For our purposes, we can also consider them documentation and non-executable. That leaves us with 4 executable lines: the assignment statements on lines 4, 9, and 12, and the print statement on lines 15 and 16. Let's watch these lines execute in idle's debugger. Most integrated development environments have a debugger, and usually you'll want to use it when you have an error in your program that you can't find. But the debugger won't be useful to you if you don't understand how each line of code in a program impacts the program state and the flow of control, resulting in either a correct execution or an error, so that's why we're going to step through this working program in the debugger. In the idle console window, choose Debugger from the Debug menu. In the window that pops up, check the Source and Locals checkboxes. For this session, uncheck Stack and Globals. They won't hurt anything, but they might be distracting. It's also helpful if you organize your windows so you can see your source code, the debugger window, and the console window. Now go back into the program window and run the program. The debugger has the following commands as buttons: Go, which runs the program; Step, which executes the next executable line of code and is equivalent to Step Into in other debuggers; Over, which steps over a call to the next executable line, such as a call to print or input. Because print and input are functions that you didn't write, you don't want to step into them. We will usually use this button. Out, if you are accidentally in a function that you didn't mean to step into, this will get you back to where the function was called. And finally, quit stops the execution of your program. Let's first use the debugger on this program by stepping through every line. We'll just keep pressing the Over button. As we do this, we can see which lines of code are executing in the debug window, and the source window highlights the line that's going to execute next. You can see the constant meal weight percentage has the value we expect. And of course, I'll have to switch over to the console window to enter data for the input statement. And then, once I've done that, we can see that the variable dog weight has the value I've entered in the console, 60. And we can see that it's a float. And we can see the meal weight variable with the result of the calculation. If at any time we see something that we don't expect and our program has a bug, then we have identified the line of code that contains our bug, or is at least giving us more information about it. Now let's try something different. I can right-click on a line of code in my program window and choose Set Breakpoint from the context-sensitive menu that comes up. The line turns yellow as if it were highlighted. So I'll do that for the line that calculates the meal weight, line 12. Setting a breakpoint asks Python to always stop on that line if I'm running in the debugger. This is handy if I have a longer program and I suspect there's an error somewhere deep into the code. I can now choose Run Module and then press Go, and the program executes until we reach that line. Now I can carefully examine the values in all of the variables, the program state, and see what's amiss if I have a bug. If everything looks right, then I can step over that line and see if the mistake is on the line itself. I can also press Go again if I've figured it out now and I want to repair my code. That's how to use the debugger. When you're done with the debugger, you can simply close the debugger window. Now that we've stepped through the program and examined the values in the variables line by line, we're going to do the same thing by hand. This is called program tracing or desk checking. We begin by making a table. I'm going to do this in Microsoft Word. Your table is going to include a column for the line number and columns for each variable in the program, as well as columns for input and output. As we learn more programming, there may be other information you want to record in a desk checking table. Before I create my table, Pause the video and figure out how many columns we'll need and what should be at the header of each column. Remember that we'll want one column for the line number. That will be the line that's just executed. One column for input and output, or separate columns for each, and one column for each variable. Pause now. How'd you do? For this program, we need anywhere from 4 to 6 columns. We will have one for the line number, one for each variable, so you may or may not have included the constant meal weight percentage in that count, and either one for both input and output, or one each for input and output. Because this is a small program, let's create a table with 6 columns and put the headings as I just described. Now we execute our program mentally. For each line that executes, we record a row in our table. We will write down which line has just executed and what the values in all the variables are after that line executes. In order to desk check, you'll need to pick a set of inputs or data for the program to run on. So let's go. We will only count the truly executable lines, the ones that make a difference to our program state, our variables. We won't count the gray area lines, the docstring, and variable annotations. Our first executable line then is line 4, in which our constant meal weight percentage obtains the value 0.03. In Python, we really say it references the value, but I'm going to sometimes say a variable holds a value. So we write 4 under the line number column, and 0.03 under the meal weight percentage column. Now that's a constant and it's never going to change while our program executes, but it doesn't hurt to show it because it's part of the program state. Our next executable line is line 9, in which we obtain the dog's weight from the user. So I'll put a 9 in the line number column, and in output we'll see the prompt from the input statement. Please enter the dog's ideal adult weight. I'll abbreviate that because it's long. And in input, we'll put what the user types in. Why don't we run our program on the value 1, our smallest value? So the user will type 1. Now technically the user is typing text, so I'm going to put quotes around that. But we convert that to a float and store it in the variable dog weight. All of this is happening on line 9, so I'm going to put 1.0 in the column under dog weight. Now I can either bring the value in meal weight percentage down, or I can only record values when they change in my table. I'm in the bring everything down camp, so I'm going to bring that down. You can do it either way. The next executable line is line 12, in which we calculate meal weight. That is dog weight times meal weight percentage. The reason I like to bring everything down is because it makes it very clear what values are in variables when we need to evaluate them. So I write 12 in the line number column, and now I can look right at my last line to see exactly what values are stored in dog weight and meal weight percentage. 1.0 and 0.03. So I can do the multiplication. I get 0.03, and this is an assignment statement we're storing in meal weight. So I'll put 0.03 in meal weight. And now finally we're down to the last executable line, or lines, and that's lines 15 and 16, which are one print statement. I'll write 15/16 in the line number column. Printing doesn't change the values in any variables, so we can bring them all down. And what is printed is the meal for a dog weighing something pounds should weigh something pounds. And what are we substituting in for our two somethings? The value stored in dog weight and the value stored in meal weight. And there's some formatting for meal weight. I'm going to write out the whole thing. The meal for a dog weighing 1.0 pounds should weigh 0.03 pounds. So that's a desk check or code trace of this program. Desk checking is a critical skill. We use it when we're learning to confirm that we understand how our lines of code work and when they execute. When you are more experienced, you will probably be able to desk check without making an elaborate table. But there is an advantage to the table and proceeding methodically. It's very easy to think your code does something that it doesn't do. If you take it line by line, it helps you turn off that part of your brain that wrote the code and thinks it knows what it does, and act more like the Python interpreter and find out what it actually does. Now that we've debugged and desk-checked this program, I recommend that you do both again from scratch. Be sure to practice setting a breakpoint as well. You can also practice tracing this program in the description box of this YouTube video. There are exercises there. Once you've completed that, you're ready to move on.